Hi everyone. Good afternoon and welcome back from lunch. I hope that no one gets sleep. I have a lot to say today, but I'm very tight on time and I hope that I'm going to deliver everything I would like to say to you. Today we are going to speak, our session is about how to effectively design your RESTful API. Okay, this is most important, how to, from the business requirement, get your final URIs that will be provided to your customer, with your customer as a services or whatever you want to do. We are going to talk about some steps in modeling and finally how to validate your API just before writing any line of code. So when you write any code, you are sure that your API design is correct and you are not missing anything. You have a valid combination of the verbs, nouns, the URL is correct. You have the minimum set of URLs that are going to accomplish all the requirements for your customer. The other one is some strategies you have to put in mind when you design your RESTful API or publish your services to your customer or multiple customers at the same time. So this is my contacts. If you'd like to take a picture, if you have any contacts, would like questions, anything. I'm an enterprise architect and development manager working for eFinance. On the other side, in the community perspectives, I'm a Java champion, JCP member, and expert group member of many GSRs. I'm author of many books, and the latest one, JavaFX Essentials. It's about JavaFX and IoT stuff, running JavaFX on multiple platform interaction with Leap Motion devices, Arduino, Raspberry Pi, mobile stuff, all of this kind of development. And I love IoT because this is the future. This is our agenda. First, we are going to talk about some tips for API modeling, okay? And the other thing, which is more important thing when you design your API, to identify your participant who are going to use your API, internal or external users. The final stage, which is more important stage, that you validate your API. So if you validating your API, revisit seeing if there is any missing requirement, then misunderstood. So you revisit your activities again, modeling again, then you will get the final requirement accomplished, start coding after that. We need to explore our medium that REST run upon, which is HTTP concepts. We need to take some concepts from HTTP to understand, like response coded, the content header, the headers that we need to focus on them so we can write a valid RESTful APIs and we can parsing on the client side. The final point in our agenda is the REST constraint. This is a design issues when you develop your API, and you have to put in mind, and when you publish, so the REST is a client server based, you have to put this in mind. It should be stateless. Somehow you can, how to make your services cacheable, how you divide your system into layers so there is no dependency between the services, okay? Code on demand, this is one of the strategies like Gmail. Maybe you open your Gmail on the fly, so you find new functionality added without you downloading new software. This is a REST capability, so you deliver your software on demand to your customer and download the code that can run this new requirement. And how to unify your resources, which is RESTful URLs. So let's go. First thing, there is 3 approaches to adding an API to your system. But before this, we need to talk about the design. The API design is hard. Why? Because you need to consider something. What functionality to expose when you're designing your API? How to expose it? On the other hand, how the best way to expose it and how to adjust and improve your API till you get the final URL that will accomplish the goal for your customer. The main problem always in computer science involves two things: naming things and cache invalidation. Naming things, you have to make sure that you're naming your services correctly, accurately, and incompletely valid for your customer, so that you will make it easy for your customer to use your API more happier. And the naming means that you just, from reading the API, it's self-descriptive. I can understand what to be accomplished without reading very long manuals to understand your API. One of the most important things is affordance. The term affordance is something which allows you to perform an action or accomplish a goal. This is what your users need to do. So this is our interaction. For our users need to accomplish something to our system, we need to map this affordances and allow the user to do all the affordances, to accomplish the requirement. For example, we have a door locker. Its affordance is to open and close the door, right? The same like switch. What's the affordance of the switch? Is to turn off and on the light, right? This is the affordance. What your things need to be accomplished or to done. This is main important point. Affordance in practice it's what the API allow you to do as a customer, what the API makes it easy to do your stuff, what the user want to accomplish. This is in terms of practice. And we are going to see how we are going to model these concepts now. Some simple example, if we have something like this, coffee cup. You know that handlers are great, right? Designed for holding the cups when it tended to be hot. So you're not burning your hand, right? Easy for holding and can be used for other things. This is the affordance of the handlers. So keep in mind this terminology. Let's now see the strategies that we are going to add. I have a system, or either the new system or legacy system. I need to add my RESTful APIs. Okay, the first one is bolt-on strategy. Bolt-on strategy is a brute force approach, but generally is the fastest way to get something workable. You already have a system, and you don't need to just up and running, and you just expose your services and enhance it on the fly. But this is the best way to get the business done and running in the fast way. It takes advantage of existing code and system. At the same time, the problem is the application tend to leak through into the application. If there is a problem in the design already, sometimes it's appear in the design of the APIs. And you have to make sure of this, and you have to make to make sure that your API is designed well. Don't make your problems in the system exposed to your API. The other one is greenfield, which is the other side of the bolt-on strategy. This is always called generally API first or mobile first methods. So you are designing your API and writing the code that exposes the functionality of that API. For sure, the advantages of the new technology, possibility to integrate your team and learning curve of your team for the new stuff, because you are designing from the beginning. Not allows always possible to drive business value quickly because you are writing code from the beginning. Okay, you have to bear in mind which strategy you are getting. The middle ground between both is the facade one. For legacy systems, especially that up and running without any problems, okay, the facade is the best way to expose your services. You just wrap existing logic and replace it as you go. Wrap existing logic and expose it and replace it as you go. Ideal for legacy systems, as application is always functional, no problem. But the main problem can be challenges with multiple mindset in the systems. This is the main challenges. But before starting to choose which strategy, I have said before, you have to make sure that your API is very well designed, right? So modeling your API is your key to the success. That's it. So let's say how to model our APIs. I want to lay out 3 simple rules you have to bear in mind. First thing, don't worry about the tools. Just any tool that works for you, use it to design. You don't have to be specific tool to work with to design your API. Whatever, it's piece of paper, it's an IDE, it's whatever you want. Just design and start modeling. Have consistent process. That means you are writing down every step. Everything should be written down. And have the same steps every time. Revisit your work and have the same step. This will reduce your risks in your API design. And if you have writing every single piece of functionality or your requirement, then later you can deprioritize the other stuff to introduce in your API. It doesn't count unless you're writing down everything. You should. Because sometimes if you didn't write anything, you will forget your requirement and you have this problem in your exposing your APIs. So if you're writing the code, then you figured out that you misunderstood something and you don't have mapping between your functionality and the affordances, you have to recreate again your API or maybe totally change your design. So the first step in modeling is identifying your participants, which is the people involved and interact with your system. Either they are external or internal users, okay? For each participant, we need to capture three things: who they are, if they are external or internal to our organization, short description, what they need to do. This is our activities and affordances they need to do in the system. For each participant, we need to capture these three requirements. After that, let's see some example about this. We have a coffee shop. And who are our participants in coffee shop? The patron, which is you, ordering the cup of coffee, the cashier, barista, and the other customers who come to the system. So you can, from customer point of view, the patron is always who is involved in the system. From the coffee shop point of view, you will find the cashier and barista, the guys who is interacting with external system, which is the patron, which is you. So you have to figure out all of these participants. All of them will interact with your system at finally. So then after that, we have our participants and we have a short description what they are doing. Let's map their activity. So for each customer, what would you like to do? So we need to just write on simple paper, this is the activity for each customer. So what our activity for our system? You place an order, you wait for an order, you receive an order. That's it. It's so simple, but it's captures the customer actions. What about the barista? What about the cashier? They are not captured. So we have to revise again. This is the second revision, okay? And this is because this is not the complete picture. The second revision, say the patron, you create an order with the cashier. So there is an interaction between both of the participants. The second, the cashier passes the order to the barista. The barista acknowledges the order and adds it to the queue. Get your name, put the cup in the queue. So you are waiting for the order. After that, an order are processed, inventory and machines are tracked. Then, at the order are ready, they are announced and delivered. The customer receive their order. This is a complete picture how the participant interacting with each other in which order also. This is more importantly. So if when you design the first one at the barista, the patron interacting with the cashier, this is the first thing you have to do with that API allows you to do. Then in order, so you accomplish everything and monitor everything. We are going to have a challenge, like we would like to order book online. And you are going to model and to apply all the steps. We are going to use the 6 steps from identifying the participant, from identifying activity, mapping activities to HTTP verbs till we get the final URL. Okay, so there is a real example we can apply through our explanation of the concepts. But just we need to book an order, and we assume that the book is available online, and in the store there is no return. That's booking an order, checking the process out, filling the cart, that's it. So first, who is our participant? You are ordering book online. Yes? Those are our participants. Maybe all of us speak about the customer, at why we involve the customer support, why we involve developers, why we involve the system admins. This is all the customers we need in our system. The developers and system admin maintain the system day by day. So there is an update, there is an up and down, they can maintain problems, something like this. The customer, for sure, you, who is ordering the book and checking the process and everything. What about the customer response? They're responding for problem. If you have problem with your order, you call the customer service. They use your API to retrieve the orders, to check out the status of the items, whatever. So they are participant in our system, right? The next step is, after identifying participant, is to identify their activity, how they interact to each other in some sort of order. So what are our activity? Place an order, look up order status, place an order. Who is placing an order? Yes, customer. Look up an order status. And customer support, right? Cancel an order, accomplished by post, customer and customer support. Adding item to cart, customer. Remove item from cart, customer. Clear cart, customer checkout process, customer. So this is our process and activities that are going to be accomplished by our participant. Okay, now we need to create and group API methods, our API methods. As we have our participants and activities, we need to group them in some sort of formal action, final action. So the customer would like to retrieve an order. So what is the term of the URL? This is the first draft of the URL. So we need to map it to the methods, HTTP methods. This is the steps we are going to go through always when we designing our API. First thing, identify the participants, identify their activities, revisit them, break them the steps down till we have the final version of the activities. After that, break them into more steps, create an API definition, and finally validate your API. Let's review our last challenges for ordering a book, as we have already our participants and we mapped our activities. So we need to group them into some sort of API, create the API definition itself. To identify the resources, always look up for the nouns in your activity. This is your resource name, the nouns, okay? So we have here item resource. And here is the list of actions that will be done on the item resource. We have items, we have orders, we have customer, we have cart, right? This is the nouns in our activities, right? So we need to get all the action done on each resource. So item resource is list items, view items, search items, add and edit items. This is simple crude scenario. The other one, the cart. You can add item to the cart, remove item from the cart. Oh, clear cart, view cart, checkout. If you just looking here for a minute, you will find a design issue here, because not all the process regarding just the cart, there is involvement in the other resource, which is an item. So you have to be creative here when you design your API definition, okay? You have to think, is the item is a part of the cart, or cart is just contain line product, and each line product has an item. Maybe if we are thinking together, we will consider the cart as a collection of items. Okay, this is our thinking and design about our API definition. We have orders resource. You need to list an order for the customer. You need to obtain an order status. You can cancel orders. This is the operation could be done on the orders. The last one as a noun is the customer. View customer, search for customers, add or edit customers. This is another crude scenario that very simple. So the design issue here is in the cart. Because there is a relationship between two resources in the system. So we need to figure out the dependency between them to map our URL finally correctly. So this is the way we are grouping. Now we identifying the participant, actions, and we now group for each resource. The tasks need to be done for each resource by the customer or your participants. We need to map these activities to nouns and verbs. Nouns mean our resources, verbs mean HTTP methods that we are going to use to accomplish our task. To map our activity to resource life cycle, we need to take the discovered action, our action that we have discovered, to map them to HTTP nouns and verbs. We need to be strictly to the normal HTTP verbs, which is get, post, put, and delete. Okay? This is the main option provided by HTTP. We are going to use it in the correct way to design our API and mapping them to our activities. So we have an item resource. You have a piece of paper. You lay down a table. Here is my activity. Here is the mapping of the activities regarding my action. We have list items, activity. We can get items. So get all items. So the first element of your URL is always the noun, which is the items. So get all items. The second one, view items. You can get item by ID. So always bear in mind that when you design, also the first thing is the resource, then the action, which is the verb. This is when you design your API. Search for item. We are going to treat the get in a specific way using the parameters, search parameters, parameterized search for get. This way you can search your list of items. If you add item, use post to add items. To edit item, use bot. If you need to delete, use delete. So we used get for getting items or searching items. We use post for add. We used bot for edit, and we used delete for deletion. This is all the crude operation you need to know about. This is a simple draft of your URL before writing just line of code and trying to create your REST resources, whatever the language is. The other activity is cart. Cart here is a little bit complex. So adding cart, you're adding item to the cart, okay? We need to think about this, how we are going to do this via simple URL. So let's discover the relationship between the items, then we can add, based on the relationship, we can add our URL and the mapping. Remove item, the same, because it involves item, other resource inside the cart, which is another resource. We have to figure out the dependency. Clear cart, so simple, delete the cart by ID, because I'm talking about the cart resources. View cart, okay, retrieve cart by ID, no problem, because I'm talking about the same resource, cart. Checkout process. Checkout process means there is involvement between the order, the item, and the cart. So let's get back to this design after seeing the relationship between the resources. This is very, very important. Complete the other resources, order, if you list an order, get order by ID, obtain an order status, and finally you can cancel order by delete an order. And the customer is another simple crude solutions, search for customer, you get and search parameters, view customer, you can get customer by ID, add customer post, and edit customer, you can put the customer with the ID specifically you have edited. Okay, how to map the remaining activity that we have exclamation mark for this, for the custom actions. So we have those items. Those what we are going to need to discover. Designing relationship. We have 3 design relationships. One of them is independent. Are they independent? The resources may exist regardless of the other existence, but may reference each other. Here is our case. Can you imagine? They are independent, like customer and order. No, customer and item. Item exists already, and the customer already exists. They can interact when they order, when there are an order. So there is dependency, they are independent together. So their existence not depend on each other. The other one, they are depending on each other. One resource cannot exist without the parent, which is customer and order. No existence for the order without the customer. Association, they are independent actually, but the relationship contain additional properties to describe it, which is, in our case, cart with item. Relationship between the customer and the item is the cart. This is the relationship we need to do. So the cart contain collection of items. So when we need to remove or delete, we are removing and deleting items inside the cart resource. So based on this, let's figure out what we are get from the relationship. But you have to ask yourself some questions before identifying the relationship. Oh, I'm sorry. Can the resource exist without another? Yes. Does one resource only exist when the other exists? Yes, cart cannot exist without items. Does the relationship between the resources require more information, just the link between them? Yes. Which in our case, the association, which is the relationship between the cart and items. So, for example here, movies. The movies exist regardless of the actors or whatever in the library. The actor defined in the movie. So the movie cannot exist without actors, without characters. So it's dependent on the characters and actors, but the actors already can play with many movies. Can act in many movies, right? So movies, if you need to get an actors of the movie, you just get the movie first by reading the actors inside the movie. And this is the relationship between dependencies and the association, independent, dependent, all the relationship. So let's figure out how we can do it in our activities. To add item, you have the cart by ID, and then items, which is the collection, and then you add the item by ID. This is the final URL to have. Because they are dependent on each other. Association between them. This is the cart, and here is the item resource after the verb. Then the final is item ID. The other one is the same, but using delete. So you're deleting from the cart number 1, the item number 1, 2, 3, 4, whatever you want. The clear, just delete. Clear all the content and delete the order. So you don't have to specify the items because you're just clearing the collection. This is how we mapped our activities to HTTP. The final step is validate your API. As the first step of identifying the resource, the participant is very important in my opinion. This is the most important one. Because if you have written down everything, when you map the resources participant to the grouping, it should be a very easy exercise for you. If not, there is a flag here. So if there is a problem, sometimes you get misunderstood. If for the requirement you miss some steps. So get back to your activity, break down them into fewer steps to get the more resources to complete your exercise till you finally get all the requirement. When you read the requirement, yes, this is accomplished the requirement, 1, 2, 3, 4, 5 URLs for my resources, done, start coding. To validate your API, write each resource's action on note card. I told you don't worry about the tool, just piece of paper. I'm doing all of this in piece of paper instead of URL tools, or notepad, text pad, whatever you want. Use Node to map each flow, action, etc., resources, mapping, that's done. Fill any gaps you might be missing, assign them to resources as appropriate. As you finally find all their activity and resource mapping, accomplish and validate your beginning requirement. Let's complete our challenge to see, okay, I would like to validate my methods. If there is something missing, let's revise and see. What about handling missing order? What an order is missing? The customer viewing order, then he didn't find his order. What we are going to do in such situation? What about reorder the same order again, last time? It involves another steps. We can break them into fewer steps. Maybe you figure out already I added API to serve this. Oh, here is a new step. I need to create a resource for this. What about canceling part of an order? Which is I would like to cancel an item from an order. We didn't describe this. We cleared all the items. So let's see this, our solution. I'm going to list my activities. Okay, customer service, list the customer order. We done this. We have URL that specify for this. Customer service, obtain the customer order status. They will get the order by ID, no problem. We already have this defined, so we are not going to do anything further. Reorder the same, customer view a previous order. Okay, they can get the order by ID. Then customer copy order. We don't have method for copying. So it's some sort of creating a new cart. You have an API for creating a cart, which is add cart for adding cart using post, then adding items. So this is accomplished by 2 steps. Getting the other items, the previous items from the previous cart. This is a new step you need to add and map to your activity. Customer check out the order. After that, this is the final step. We already done this before. What if part of my order is wrong? Customer service list the order. We already done this. Customer service view the active order. They can get the status of the order. Customer service cancel a specific item. They can use the resources we already created. This is a new step. We didn't write this step before, but when you think in the design, you just canceling an item inside the cart of your order because the order is described by the cart. So we already have a URL for this. This is how you validate what is the missing in my requirement? What if something to accomplish like that we have figured out and we trying to recreate them again, reorder them again to figure out what is missing to the final API design and definitions. This is, till now, you are done. You're finished. You're finished your code. It's not your code. You're finished your design. Laying out the design, the project is okay. The developers can start writing the code to accomplish each affordance for the customer. Any question till now? Great. We need to just some simple overview of HTTP because this is the medium that the REST API depends on, and how we can use specific item of HTTP that serves the client from the server. HTTP is a great tool because it's understood by most client, most browsers, most client, and tools out there. Underlies the entire web. So REST run up an HTTP. So we are going to use all the requirement and the specification of the HTTP to serve our RESTful APIs. REST is not a standard. There is no standard for REST. Even in Java, we're creating GSR for JAX-RS. This is not a standard. This is the way how you interact with URL. You don't find any book writing that you have to write the URLs in a specific order on specific design issues. It's just best practices. And all what I'm saying is best practices. So REST is not a standard. REST is not a pretty URLs, not necessarily XML or even JSON, whatever you want. It's depending on your media you would like to exchange. It's maybe some URLs It's not just like this. REST is generally agreed upon set of principles and constraints. When you design your REST API, you have to bear in mind this. It's just principles that we have said when you design and the constraint that we are going to see. Compare them like soup versus REST. It's like mortgage versus borrowing $10. When you need to mortgage a home, you have to get some sort of documents, go to the bank, sign the document, take a long process, then you begin mortgages your home. This is a long process. This is a soup. Envelope, header, specification, then you can interact with me. Borrowing, I can borrow you now $10 on the dinner, and you can get back to me by $10, or you don't have to give me back the $10. You can invite me for a dinner with the $10, no problem. It's flexibility. It's add a ton of flexibility to you. But bear in mind, flexibility means you have to take care of your design, because if you don't care of your design, you will have a messy URLs and design. HTTP, as we have said before, well-understood protocol, simple and powerful in its implementation. HTTP response and payload. Every HTTP response have a request. And the most important thing in this is the status code. Bear in mind this, content type and media type. Those characteristics and headers you need to concentrate when you design your RESTful API. Let's see HTTP headers. Why HTTP headers and response coded? Because this information is hidden from the user, but most of the tool can read it. And the codes, you can parse the request, get the headers, and get all the information from the status code, the media type, and the content type, which is more important than REST. In order to access payload, for example, you have live headers, add-ons on the Chrome and Firefox. You can use it to capture the request URL and know your properties. You have Postman, add-ons in Chrome, great client tool, and for sure curl, command line. You can capture your request. When I run this URLs, I get bunch of headers, which is more importantly is the content type. Okay, this is describe the payload and the status code. What's happening on the server side? It's okay, it's bad URL, it's exception there, so you can interact with this response code to your customer. Most important header is the status. This is the response code of what you are trying to accomplish, either successful or failed. Content type, this is identifies the type of the payload being passed back by the server. So you know this is JSON message, this is an XML, this is whatever the payload. So you start parsing it based on the content type. The media type, it describes the actual structure of the payload and how things work together. So most of the HTTP responses classes, we have 100. This is informational classes. You need to use this. We have 200s, which is success scenarios, 300 for redirect, 400 for client, and 500 for server errors. You don't have to know all of the status code. Just concentrate on, okay, 201 mean created, 202 mean accepted, and 200 for no content. No content always used for updates. If updates goes well, when you put, okay, you return 200 code. And 4. Responses for 300, when you're trying to access URL, you can return 300. This is moved permanently to the new URL, for example. 302 moved temporarily when you are trying to maintain your service, for example. 400 bad request, authentication required. This is for authentication. You can use it. This is forbidden for accessing URL that you're not allowed to access. And 404, which is not found URL, that you're accessing wrong URL. Response code are great, right? But don't try to create your own, because you have enough response code to use. Because if you add your own, you're adding new complexity to the tools and your customer. So make it easy and natural because this is the entire web understand all this response coded, and it's enough for using in your code. We have 16 minutes, okay, or 15 minutes, or maybe less. This is the other side when you design your API. I'm going to go through quickly, I'm sorry for this. The REST constraint mainly, when you think designing client server based. Don't depend both of them. You have a client that is, they are not aware whatever you're representing your server. Just provide URLs. Remove any dependency between like IPs, ports, whatever. Just name domain. Like when you developing with daily coding, you're putting in your server in the database pool the IP of the rack of the database. Suddenly you will find the DB team changed the rack and you're running the server. Okay, it's not running. What does that happen? You figured out that they are moving the rack to another IP. So you have to figure out, I'm using the domain name. So whatever the changes, I'm not depending on the server. Remove dependency. This is the same. Stateless. Stateless because you have to be stateless. You don't have to many process to authenticate first. Some of you will tell me, what about authentication? I'll show you something for Twilio API, how they design their API with the authentication. Cacheable. How to make your API cacheable. You have to follow some steps, and there is a great tools to cache your API. Like GitHub. GitHub do a lot of caching for some verbs or for items like not boast, forget. If you're getting resources, you need to cache something because you're getting your account every time. There is no change your account if you create new account. So when you require an account, don't get the payload, get it from the cache. So how to you maintain your cache for RESTful web services? Layered system, how to expose your functionality from different layers, to remove dependency, and code in demand. This is feature that you have to address when you provide services for your customer like Gmail, like Twilio. They provide new features as they go without you downloading new software or downloading any extra software. So the download for your site JavaScript code and the other component that act on this code to run it for you. You will find new tabs, new functionality without your interaction. And the most important one, and to unify your resource. So when I'm reading your URL, it's self-descriptive. When I'm getting the payload, it's self-descriptive. I understand what you need for me to parse or accomplish by this URL without reading a lot of manuals. If you're providing a lot of services, if you're trying to figure out the API for Twitter or Facebook or Twilio or some public services like this, when you're reading the API or for GitHub even, just reading the URL, you will understand what they need. Here is, I can read my account. Here is the list of my tweets. Here is the list, without going too much into the details. It's web browser and web services. This is the client-server interaction. By separating the two, we can vary them. Server serves the scalability and reliability between you and your customer. Stateless means stateless API. Each request stands its own. No URL depends on the other. So it should be stateless. When you request an item or request an order, there is no dependency on other URL to call. Requests can be processed in any order, no problem, because sometimes they will be. Something like this. This is the Twilio API. You're just calling for messages. Okay, did you see the account? Accounts? This is your account on Twilio. This is a security issue. You have to provide an account, but this is stateless. You don't have to wait for authentication and get back and then go to call your messages or records or send messages. It's in one action. Authenticate, send, authenticate, get the data. It's one action and one order and process at the time. Stateless, why? Flexibility. for sure, stability, because there is no dependency, no more headaches. It's just one URL means one action. Reliability, and you can add more actions after that. Caching and cacheability mean cacheable API. Each message should be described whether it's cacheable or not. Improves network and application usage. Makes the system more reliable and scalable. If you're caching most of the data, that it doesn't change on your system. Most cacheable verbs is get, put, and delete. Should be important or safe. Safe in terms of cache. You can cache them because when you get any data, you're just getting data from the database or getting data from your account. There is no change. Put, you are editing something or deleting something, could be cacheable. The word safe means that a given HTTP message is invoked. The resource state of the server will remain unchanged, whatever you invoke this. Post can be used for multiple operations, so it cannot be cached. There is a technique called e-tag. This is used for caching. Built in for caching signals. This is make your signals for your API that this API is cacheable. Generate for individual request sent as a header data, compare to see if they has changed, because it's somehow it's a combination of hash of the time of the request and the data changed. If there is any change, they will change the tag. So the signal, it's invalidation for the old cache. So you have to process this, it's not cacheable. Available via headers, head verb. For example, if you go to HTTP e-tag and they will describe all the specification and how you can add it to your API and use it. Something like this. This is GitHub request. So you will find here, this is e-tag. It's some sort of hashing in terms of time, in terms of the content hashing, all of them, and give you a specific message. REST constraint, layered systems, code on demand, which is optional, and unify the resources. Layered system means don't count on the client, interact directly with the server. You can have broker in the middle or front end that serve the customer and the back end separated from your customer. So you can add more flexibility and reduce the load. We use this for web every day and single day, for sure. Add silence, invisible dependencies. Why? Allow in between system to add and remove functionality on the go. Allow load balances, caches, logging, authorization, and all of this component that you need during your system without loading your server. Just your server at the back end for your functionality. Code in demand. Code in demand. There is a lot of debate on code in demand because you install the code on the client side. Oh no, this is a security issue, but Google provided for a long time. In Gmail, for example, this is private mail. A request does not just retrieve the resource, but also the code that acts upon the request to run it. We don't have to know or understand the code, just how to run it. That's it. Allow for flexibility and upgradability. It's a nightmare, yes. Execute the third-party code in security nightmare, yes. But Gmail do it for a long time. Uniform interfaces. This is the final one and the most important one in our constraints. Should be present in every API. Whatever the API, this is very simple rule and most important rule. It is most complex but most powerful one. Uniform interfaces principle, identification of the request, manipulation of the resources through these representations, self-descriptive message. It should be hypermedia as the engine of the application state, HATEOAS. Identification of the request. Okay, this is the first part. How? Generally use noun and the action when you design your URL, but don't use noun n equal noun and ID equal. Unify your URL. Don't vary your URL description. No, it's resource then action. Resource then action. Whatever the combination you design. follow this. So all your API, when I see it, I know this is the resource, this is the action. Manipulation of the resource through this representation, how? Like Twilio. Twilio have only 3 URLs to add all of your information and interacting with the systems. It's begin with the accounts for security reason, account SID. You have calls, you can get the call by call ID. You have recordings, you can retrieve it. You have messages. Either you need to send the message or retrieve the message to read it. For all of them, you will find Git for all the information to get the information, post only for calls and SMSs, put not enabled, and delete only for recording if you need to delete. That's it. This is the specification of Twilio. So simple. Self-descriptive, how? Self-descriptive, each message should tell you if that resource is cacheable, how to process itself, how to request the next resource. Sometimes when you're calling your account, let's see an example of this. This is complex one. Something like this. This is the request. Get account 12345. This is my account. Then you have returned an XML with a bunch of other URLs. So it can be processed without your interaction. I'm giving you the links if you would like to deposit, withdraw, transfer, or close this account. So I'm providing for you the next steps, the next URL you need to interact in your page. You just need to click the link to request the other function without worrying about how I'm going to add this function. I'm just giving you one URL, just get the account, and I'm going to provide you all the services after that in form of URL. And you're going to parse this and just URL in the system. Retrieve my account, you'll find page telling you, okay, this is valid account, you can deposit, you can delete the account, you can close it, you can transfer, you can whatever you want. But I'm just parsing the payload and providing next till you finish your application requirement. Something like this. This is HATEOAS example for GitHub. If you request, you will find messages contain all the URL that you can work on upon this, and they can add the functionality. There is a current user URL, user authentication, HTML, authorization URL, code search, whatever, the key URL, all the URLs that you need is provided as a message. So you can parse it, you can add it to your page, just clicks. Whatever is the URL entirely changed in the background, you don't worry about to change it because it's provided each time by the server. So think of this when you provide your service to your client. This is our goal, and this is the final. Thank you very much for listening. I don't know if you have questions.
We don't have it.
Do we have time for questions? No. I'm standing there. You can ask me whatever you want.
You're trying to show me a fender, I told you before, that don't impress me.